Okay, so this tutorial is about double replacement and neutralization reactions. They kind of go together because a neutralization reaction is a double replacement reaction, a special type. So first we'll start with double replacement. Double replacement is when you have a reaction between two compounds, and then after it reacts, it results in two different types of compounds. Essentially what happens is that the metals switch with each other, and it's like having new dancing partners. So the general formula is if we have compound AB plus compound CD, A and C, the metals, are going to switch places with each other. So now A is with D and C is with B. So here's some example. Sodium chloride plus silver nitrate. Sodium and silver switch places. So we get silver chloride and now sodium nitrate. Double replacement. Another example. Sodium carbonate reacts with iron chloride. The two metals, sodium and iron, will switch places. So now iron's going to be paired up with carbonate, iron carbonate, and sodium's now with chloride. Neutralization is a reaction between an acid and a base, and when they neutralize, they form a salt and water. Remember, a salt is any type of ionic compound, and remember, an ionic compound is a metal plus a nonmetal. So neutralization is a special type of double replacement. You must have an acid and base, and it has to form salt and water. You know you have an acid when it begins with an H. You know you have a base when it ends in OH. So when an acid reacts with a base, you get a salt, ionic compound, and water. So hydrochloric acid reacting with calcium hydroxide, your base, you get your salt, calcium chloride, plus water. So here we have two reactions. We're going to figure out if they are double replacement neutralization or just double replacement. So remember, in a neutralization reaction, you must have an acid reacting with a base. So the first one is phosphoric acid reacting with magnesium hydroxide to form magnesium phosphate and water. The second example is silver nitrate reacting with magnesium chloride to form silver chloride and magnesium nitrate. What you should have noticed is that here we have an acid and here we have a base. This is our salt and this is our water. So this one is your neutralization / double replacement reaction. The second example, it's two compounds and the metals are switching places, but there's not an acid and base, so it's only double replacement. Alright, so let's balance our reactions. Let's start with the neutralization double replacement reaction. So I am going to look at my compounds. Here we have phosphate and here we have magnesium. And I'm going to start by balancing those two. So on the reactant side, I only have one phosphate, but here I have two. So that means I need to write A2 in front of my phosphoric acid. Then I'm going to take a look at my magnesium. For the magnesium, there's 3 of them. So in front of my magnesium hydroxide on my reactant side, I need to write a 3. So now the phosphate and magnesium is balanced. I have to make sure all my hydrogens and oxygens are balanced. Well, I left that for last because it is a little bit more complicated. Remember that this water is formed when the H from the acid comes together with the OH from the base. So H2O is technically one H and one hydroxide. we can use that information to figure out how much water we need to balance out this reaction. In the reactant side, if we look at just our acid, when we multiply 2 times 3, it's telling us we have 3 times 2, which is 6 hydrogens coming from the acid. Then we look at our hydroxides, 3 times 2. That's telling us we have 6 hydroxide coming from our bases. So that means if 6 hydrogens react with 6 hydroxides, we're going to get a total of 6 water. So that is the coefficient that we need right here to balance. And this is a 1. Okay, so let's write out our last reaction and balance it. Silver nitrate reacts with magnesium chloride. They're mixed together, and what we get produced, that's where our arrow goes, is silver chloride and magnesium nitrate. These are all ionic compounds, so you have to check the charges for every single one before you make it. Silver is a +1, nitrate is a -1. So silver nitrate is AgNO3. Magnesium is a +2. Chloride is a -1. So magnesium chloride is MgCl2. Then we get our arrow. Silver chloride. Silver is +1. Chloride is -1. So it's AgCl. And our last compound is magnesium nitrate. Magnesium is a +2. We said that before earlier. Nitrate is a -1. So it becomes magnesium NO3 2. Balance out the charges. All right, now we just have to balance out the reaction, make sure their atoms on the reactant side is equal to our atoms on the product side. Notice that we have 2 chlorines here, but only 1 there, so that tells us we need to put a 2 in front. And then the other thing you should see is there are 2 nitrates on the product side, only 1 over here, so we need a 2 in front here. Check the rest of the stuff. Our silver is good because there's a 2 here and a 2 there. And magnesium's fine because there's only 1 here and 1 there. Nice and balanced.